In 1929, you could buy a refrigerator with no plug, no motor, and no compressor. It looked less like an appliance than a piece of laboratory equipment. Two metal balls joined by a curved pipe. To make it cold, you did something that sounds completely backwards. You put one end over a flame. It was called the Crowley icy ball. And for families living beyond the electrical grid, this strange machine offered something close to magic. Fresh food and even ice, powered by heat. Before electricity reached rural America evenly, keeping food cold was a daily problem. Ice boxes worked only where harvested ice could be delivered. Mechanical refrigerators existed, but a farm without power could not run one. Powell Crowley Jr., already known for making affordable radios, saw a market hiding in that gap. The key design came from Canadian engineer David Forbes Keith. His United States patent, filed in 1927 and granted on Christmas Eve of 1929, described an absorption refrigerator built around two connected spherical vessels. Crowley's company acquired the idea, refined it, and sold it as the icy ball. Its operating cycle was simple to describe, even if the chemistry inside was not. One ball held water mixed with dissolved ammonia. The other was the cold ball. In the morning, the user placed the cold ball in a tub of water and heated the generator ball with a kerosene burner. Heat drove ammonia out of the water and across the connecting pipe, where it condensed inside the water-cooled ball. The patent even described a whistle that could warn the operator when the heating stage was complete. Then the flame was removed. As the generator cooled, it became hungry for ammonia again. The cold ball was placed inside an insulated cabinet. Liquid ammonia began to evaporate and travel back toward the water in the generator. Evaporation pulled heat out of the cabinet. The ammonia was reabsorbed, and the food compartment became cold. There was no electric motor turning a compressor, no continuously moving mechanism. Heat had effectively charged the refrigerator, and chemistry did the rest. According to the American Society of Mechanical Engineers, a working icy ball could hold its cabinet near 43 degrees Fahrenheit for roughly 24 to 40 hours, while also making ice cubes. For a farm beyond the power lines, that could mean safer milk, preserved meat, and fewer trips to town. But the icy ball asked its owner to become part of the machine. Every cycle required a flame, a tub of cooling water, careful timing, and physical handling of a pressurized ammonia system. The process was clever, but it was not automatic. And while the icy ball solved the absence of electricity, that absence was slowly disappearing. As power lines spread into rural communities, electric refrigerators became easier to use and increasingly affordable. You closed the door, plugged them in, and forgot about them. Crowley itself moved toward conventional electric models. In 1933, the company introduced the shelvator, remembered for putting storage shelves inside the refrigerator door, a feature that survived even after the icy ball faded away. The icy ball did not disappear because it was imaginary, or because it could not make things cold. It disappeared because the world around it changed. It was a remarkably good answer to a problem that infrastructure was about to remove. Its central idea never vanished completely. Absorption refrigeration still appears where heat is easier to obtain than electricity, including gas-powered refrigerators used in some recreational vehicles and off-grid systems. The icy ball looks bizarre today because we see refrigeration as a box with a power cord. But in 1929, it represented a different possibility, that cold did not have to come from electricity. Sometimes a forgotten product is not a failed idea. It is an idea built for a world that no longer exists. This is Ordinary Relics, the forgotten objects that build modern life.